Okay, now we're on part 3 of our exam review explanations, and now we're going to be talking about quadrilaterals, so this is more recent stuff. So we want to find the values of the variables, so we want to find x, y, and z. So the first thing we know is that opposite angles in a parallelogram are congruent, so z will be 96 degrees. We also know that x is alternate interior with 31, so x will be 31 degrees. And then we know that same side angles, so the 96 and this entire angle have to add up to be 180, so I can simply do 180 minus 96 and then minus another 31, and that will give me what's left. So 180 minus 96 minus 31 gives me 53 degrees for y. If ABCD is a parallelogram, angle CDA is 57 degrees, so CDA 57 degrees. If you want angle BCD, those are on the same side, so same side supplementary, 180 minus 57. (123 degrees). In problem 24, measure of angle 2 is 4x minus 20. The measure angle 4 is 3x minus 11, and we want to find x. Opposite angles are congruent. So if we subtract x, add 20, x equals 9. Then we need the measure of angle 1. So if we substitute, we can do 4 times 9 minus 20. That would give us 16 degrees. That would be angle 2. So angle 1 would equal 180 minus 16, because these are on the same side. And angle 1 would be 164 degrees. Okay. Look at number 25. We want to find the length of A to M. We know that PN is 15 and AO is 6. So if I'm just finding AM, this is extra information. I don't need to worry about it. Since the diagonals of a parallelogram bisect each other, each piece is equal. So AM would equal 6. For 26, I want to know if, given this information, I can decide if this is a parallelogram. So XN is congruent to NZ, and NY is congruent to NW. So since these are the diagonals and they bisect each other, then yes, that's one of the characteristics of a parallelogram. Which description does not guarantee that a quadrilateral is a square? Has all sides congruent and all angles congruent. Well, that would definitely be a square. If it's a parallelogram with perpendicular diagonals, the problem with this one is it could be just a rhombus. So this in itself does not guarantee that this is a square, because we say nothing about the angles. A rhombus also has perpendicular diagonals. For number 28, the most precise name for the quadrilateral ABCD. So if we draw quadrilateral ABCD, we want to decide what kind this is. So if you remember, you need to do the distance formula for the sides, and then you need to check the diagonals. So right now you want to pause your video and work out the distance formula for those, and then which one it was. So hopefully you get from this that opposite sides were congruent, which makes it either a parallelogram or a rectangle, and then we check the diagonals, and the diagonals were not congruent, therefore you have a parallelogram. And then our final question here is, we have a rhombus. The measure of angle 1 is 15x. The measure of angle 3 is 30z. And the measure of angle 2 is x plus y. So the first thing we're going to do is remember that diagonals are perpendicular. So each one of these angles is 90 degrees. So if we solve for z, we're going to do 30z equals 90, so z is 3. If we do x, 15x equals 90, so x equals 6. And then for angle 2, we know that 90 equals 6 plus y, so y equals 84. And that concludes part 3. Stay tuned for one more part.